Everyone, welcome back to the Raku reviews, and now we will take a look at the task number 2, flip array of week 83 of the weekly challenge. So the task here is, you've got an array of positive numbers. Write a script to flip this sign of some members of the given array so that the sum of all members is minimum non-negative. Right, so there are some numbers and we have to basically add them up, but you are allowed to subtract some of those numbers, right? Basically, yeah, how many you want, you can subtract. For example, here you subtract the second number and you get 1 in the end, and it means that you need one flip, like basically one minus, to get this minimum sum. And here for these three numbers you can put minus here, and again you need only one minus to get the minimum non-negative. Yeah, 0 is also okay. So let's look at the solutions, and let me start with my solution because I can explain my solution easily. So here it is, my solution, Raku number 2, and here it is. So there are some numbers, right? Yeah, so actually maybe it's a bit different from the task. This is the task, right? Because I wanted to to have more, like, bigger numbers of flips. So what I'm doing here, so first I'm trying to basically use the bits in binary representation of some numbers, and this is why I use this format in string, and I'm using here in dot format. But yeah, definitely there are better ways, simpler ways in Raku to get the binary representation, but I need leading zeros because I want, like, I need 3 different bits always, even if they are zeros, right? So this is where I'm doing this. Well, some indentations lost, but nevertheless, so from 0 up to 2 to the power of the lengths. So basically from 0 to 8 to 7, up to 7, including 7 for these numbers. I've got these bits, and well, actually it's not bits, it's just characters, because I'm splitting the string into characters, and I've got characters here, and the characters are 0 and 1s. And after that I take all of them and I replace zeros with -1. So in the end I will have, well, after this transformation I will have +1 and -1s, and I just multiply those by the original numbers, right? So yeah, basically here is the zip operator plus the multiplication operator, and what I will have like 12 multiplied by 1 or -1, 2 multiplied by 1 or -1, the same for the others, and after that I add those multiplications up. So that's it. If the sum is negative, I skip the rest, and if it is not negative, I just try to find the minimum one. But I also need to count number of flips, because we want to have the minimum flips, right, to get the minimum number, the minimum sum in the result. So yeah, that's why there are like minimum sum and minimum flips counters, well, not counters, variables. And yeah, and to count the flips, I just count the number of zeros in my bits. Remember that 0 actually represents the minus. That's it. So after that I just print the number of signs, the number of flips, the minimum sum which I get. So let's run this one. Raku Ash, Raku 2. So number of sign flips is 2, minimum sum for this example is this one. Yeah, basically. So yeah, because there's quite a big number, and I can subtract all other numbers from that. So yeah, that's 2 signs, and that's the minimum sum, the minimum non-negative sum that I can get. Good. Arne Sommer, Raku number 2. So here's the solution. What we have here, we have the subset of positive numbers, not integers, by the way, and the main function, which takes some numbers, at least one of them. They are all positive. After that, we just do it. Let's do it. So yeah, it looks like it's a recursive algorithm. So originally we pass the input data into some empty list. After that, so it's left and right. Okay, so after that we take the item from the right array, so basically from the original data first, and If there's nothing there, right? If nothing left, then you do something. But if there's something left, then what you do, you take the left part and you either add or subtract the current item from the right array, right? And you repeat the procedure. So basically you will take elements one by one and you will just try either plus this element or minus this element in the total amount. Yeah, and as soon as you reach the end of the data on the right side, you are allowed to, so sum left sum push. So there's some hash. Probably it collects the, well, something. Looks like it collects the options, right? Which give us the minimum sum. Okay, so this sum will, some hash will give some information about which sum you can get with which numbers, right? And after that, so you get the lowest sum. So first of all, you grab the amounts which are positive only. I wonder, by the way, if we can use this positive subset here somewhere. Yeah, probably tilde, right? Like star, tilde, tilde, positive. It's not positive actually. Yeah, it's non-negative, but yeah, nevertheless. Okay, minimum. So that's the lowest sum. After that, you use this lowest sum. You take all those options, the candidates actually. Here's the name for us, and loop the candidates. And after that, take the candidates, and for each of them, actually, yeah, I see. So here's the array, right? So what you do, some index which will keep its state. You flip candidate grab. So you keep the things below 0 and you count the number of them, and okay, match index candidate join index plus plus, and you do something with them. So flip. After that, the number of flips minimum. Okay, so this is it gets the number of flips, right? So the candidates which are below 0, those are okay. So yeah, those are these which came into this array with a minus, and we count the number of such elements, which is basically the number of flips, and yeah, we just count this number. Right, so and after that you just take the minimum. Okay, I kind of understand this. Raku, Arne Sommer, Raku, Ch2, and I need to pass it some numbers, right? I need to pass it some numbers, and I believe the best thing is just to take these numbers, 12, 2, and 100. 12, 2, and 100, so it should be 2 flips. Oh, wow. 1. Let's maybe do it like this and like that. So this is my candidate. There are 2 flips. Why is it like match? I believe this one was not found, right? It gives us the minimal amount of things. Or did I misread Perl weekly challenge? And let's look at the task again. Flip array. Write a script to flip the sign of some members of the given so that the sum of the members is minimum non-negative. Given the array procedure, you have to flip the sign of some of its elements such that the resultant sum of the elements of array should be minimum non-negative, as close to 0 as possible. Return the minimum number of elements whose sign needs to be flipped, such that the result sum is minimum non-negative. No, actually I read it correctly. So what we have to do, we have to find the minimum sum, the minimum positive sum, which is 86 here, and the minimum number of flips. But this thing gives us this one, right? Its sum is 110, which is not the minimum thing. This is the minimum sum. Okay, right. Okay, right. Going next, Jan Krnavek, Raku number 2. So we take the array from command line, we flip array. So right, so there's the sum directly. After that, we take the number of, well, the indices of those, right? We find all those combinations and we minimize the thing. What do we minimize? We try to find the minimum of this and then count them, right? So sum minus 2 multiplied by mod, oh my god, combinations. Okay, so after that, so here this part I understand. So these are the list of indices, right? 0, 1, 2, 3 up to the size of the array. Then we got all those combinations that we can combine out of those, and actually we have to find combinations which include all the things, right? All the items, all the indices. And here in $_ we'll have the combination, the current combination. We flatten it. We take a slice. We take a slice and we take the sum. For some reason we make it double and we subtract it from the original sum. Because we want to find, and for some, I don't understand why we need this, but maybe let's just run this Raku 1 bash Raku 2. Actually, there's the test key which runs the tests. They all pass, but I definitely want to pass to check my data, and that's correct. Good. Okay, good. Going next. Kang-min Liu, Raku 2. So we flip elements from the command line, and what it does, so first it's this, so it's a similar solution, so at least it starts similarly, some number of so it's the sum, it's just the copy of data, the minimum sum, for the outer loop with label k, and we break it here, 1 to the last, so we scan the thing, we scan the indices, excluding the first and excluding only the first one, right? After that, we take the combinations of the original data, original items, and we try to find combinations of different lengths. And after, it's kind of the same. I don't understand it. And if this is if this sum is is less than the minimum sum, then we try to keep the solution. And after that, we count the elements in these mean combinations. Okay, Raku Raku 2, 12, 2, and 100, and this is the combination. So maybe we can understand the solution by looking at the output. And here it is. So 86. That's the result, right? That we saw here, which you can get by adding up this. So this is okay. I don't know why we need 2 here. So minus twice. Okay. So first you. Now I understand it. I understand this 2 multiplied by, but I still don't understand those mod by 4. So why we need these 2 here? Because we subtract those elements, so we add them up, and these are the elements where we put minus before them, so something like here, minus 12, minus 2. So for the first unit, we'll just kind of remove these, so we get rid of those elements, and when you subtract it for the second time, you actually will subtract that from the remaining things from 100. So in the end, it will give us 100 minus 12 minus 2. So simple, if it is simple. Right, so so the method is just to find the sum of all the elements, and after that try to find all the combinations which you can combine out of those, and basically subtract them twice, and after that you will get the sum. With some very variation of some flips of plus and minuses, right? Okay, interesting. Going next, Mark Anderson, Raku number 2. So we've got some data which are positive unsigned integers, all of them, and this is at least one of them. We gather together, we gather this, so gather take, and after that we classify them. Ooh, that's cute. I can't say that I can read this immediately, but the fact of using classify is an interesting thing. So for all those, so a.keys are the indices. These are the combinations of indices. Yeah, we definitely want only indices, well, only those combinations where there's at least one index, right? Okay, yeah. And after that, so we take that as C, and we take the slice and we map all those elements. Okay, so yeah, it's the it's the combination of the previous method with a more straightforward method, so without like subtracting it twice. So we flip the sign of those selected in elements with indices in at C, and basically, yeah, after that we just add everything up, right? Because here we flip on the copy of array, we flip some signs for some of the elements, and we take, yeah, we take some data, and after, but it's not it, right? So because, so here we basically try to find all the possible like these, right? And after that you need to find the best. So you minimize the value is probably the sum, and the key is, no, value is, yeah, this is the key, this is the value, if I'm correct, right? I don't know. Right, so yeah, basically you just minimize everything what you can, both the sum and the number of flips. The number of flips, it's here, right? Definitely it's tail, and head is the number of, right, the sum. Mark Anderson, Raku 2, 12 to 100, and it's 2. That's correct. Right, Markus Holzer, Raku number 2. So here's the solution. I want to syntax highlight it. Well, not that much. Okay, then let's look here. So there's this function, the function. That's cute. And we are, where are we using it? We are using it here. We're using it recursively, right? Find and count all negative numbers of all possible candidates grouped by sum, filtered where sum is positive, sorted by sum, closest to 0, the one with the least flips. So this is less than 0, and we minimize that, find the minimum of those. Okay, but basically everything is written here, so I don't understand neither this nor that. But so yeah, less than 0. So at least I understand this plus, right? So it gives us the number of elements, I believe. So we take that, all possible candidates, right? So plus dollar underscore minus dollar underscore, we cross yeah, so we take all those elements of the original data, we create a pair plus and minus for each element, and we basically apply this reduction operator. Basically we create the cross product of those, right? And it's kind of the multiplication table, but with these elements, right? After that you take the sum and you classify that, and you only need, yeah, bigger than -1, I would say just more than or equals to 0, right? It's the same. After that you sort the key so that the head element is the minimum element automatically after the sorting, and after that you still want the less than 0, the one with the least flips. Okay, this last step is still not quite clear. Raku, Markus Holzer, Raku 2, 12 to 100, 2. That's correct. That's cute. I like this solution. BJ Durai, Raku 2. Right, so what we have here, so we have a couple of test cases so that we cannot test my solution, but I will do that still. Solve, result pair, reduce sub, right, so there's this sub which ends here, and you return the first pair, and what you apply it to, I mean the reduce function is here and the data is there, and these are the combinations of infinity and 0 and all those indices, right, as we saw before. These are the indices or indexes as it's said here, and this is accumulator, I believe. For indices elms, so if there are some indices, set the indexes to negative of those values, right? Sum up the array, that's right, that's okay. That's if the value is less than the previous attempt, remember the value and number of negative elements. That's clear. And clear the negatives maps. Yeah, I don't know. So you remove the sign of those, right? Ah, by the way, this is how you can make all the elements positive, right? And after that you return this thing. Okay, I didn't get it, but I want to run it. BJ Raku Ch2, so let's run it. Right, that's right, but now let's run it for the test case, which is not that trivial, which is 12, 2, and 100. So it should print Raku, it should print 2, and it prints 2, which is really good. Going next, Simon Proctor, so main function takes the elements and lazily gathers the elements. Okay, so lazily gather elements, number of elements. So these are -1s repeated a few times. So that's the maximum. Yeah, that's the 2 to the power of the size, right? -1. Okay, that's the format, the thing I used, but it's a different type of format, right? It's D. And after that, 4. So we scan that range, right, up to maximum. Actually, yeah, just okay. Yeah, that's good. I mean, this max, if it's used anywhere else, probably we don't need this -1, and we can just use hat instead of this, but nevertheless. So we take, what do we take? We take -1s, right? The list of -1s, plus, well, zip plus, yeah, so basically we apply it for everything. Okay, so yeah, exactly, yeah, so okay, so yeah, that's the combination of all the methods. So what we do here, so we have here the binary representation, right, 0, 1. Using this format, the format says that we want leading zeros, right, like here. After that, really, so no, n base sprint format. Okay, so this part is the format. Okay, now I understand it. Yeah, it's simple. So this gives us the binary thing, and this basically adds the leading 0 as the format, right? The format in string takes the decimal number and appends a leading 0s to it. Okay, so in the end it gets the same as in my solution. So some binary representation of this number with leading 0s. We split it into characters. We map, basically we convert all those 1s into 2, and 0s become, oh yeah, they remain being 0s, and we multiplied some of them, basically those which have 1s in the binary representations with set bits. We multiplied it by -1, and we basically kind of get the mask containing the -1s, right, in different places, and we get it in flips. So these are the flips. Yeah, probably I even want to maybe print the thing, this thing, DD flips, so it will even maybe, actually, yeah, let's run it. Okay, Raku T, so 12, 2, and 100. No, cannot erase the list. Why? Line 12. Okay, but I don't need this laser then, right? If I want to print these flips. Right, so this is the flips array. It's a list of, well, it's an array of sequences of all those possible combinations of signs, right? Right, that's cute. That's interesting. So yeah, basically the task is split into two parts. The first is just to prepare the minuses, the combinations of flips, and the second is obviously, yeah, we are multiplying the flips. Here's the f flip by the number, the original data, and we've got the sum of them, right? By using the reduction operator, we skip the item if it's less than 0 or if it's bigger than the minimum that we already found. And after that, yeah, we'll definitely save the minimum, and the clips is flips is the counter of flips, right? The number of flips. And again, we skip the thing if it's bigger than the previously found number of flips. Okay, that's good, but we already saw that this method gives this correct result for our data. Interesting, really interesting thing. Okay, Stuart Little, Raku 2. So we take, okay, again reduce and CM pair, so and minus. So that's the half of sum of all those elements with pluses, obviously. After that, it's not recursive, right? After that, so here we've got all the combinations of the elements of not indexes, right? And in the end, we take the first thing. And so what? I don't understand this construction. Well, actually, yeah, I do. So that's returns a pointy block, basically an anonymous function, which takes two arrays A and B and returns something, right? Well, basically it returns either the array or the maximum of this. Yeah, okay, and what is cap? It's this one, right? It's like the half amount, half thing. Okay, I want to run it. Raku Stuart Little, Raku 2, 12, 2, and 100, and the result is extremely correct. So we reduce this, so this thing returns us function, right? We then use this function probably with all this stuff. Okay, and this is the combinations of, yeah, all those possible combinations. And right, so so we just subtract. Okay, so I understand it now. So remember those solutions where we multiplied something by 2, and here actually we did not multiply it by 2, but we divide the original sum by 2, right? And after that we can just subtract everything, and we will not get the sum, but for us it's not important because we are only willing to find the thing with the minimum thing, right? Right. Okay, good. And we continue. The next solution here is the solution by Athanasius, Raku number 2. So here is the solution. It starts with the main function. We accept some elements which should be pos. What is pos? Pos is the positive integer. And right, so after that we compute the sum. Mean flipped sum. We estimate the mean sum first as the initial total sum. Numbers to flip, and so we take all the combinations, right, the comp list, and next, if there are no elements, or if the elements are the same, if the number of elements is the same, which means that all elements are the same. No. Okay, so that we have all the elements, right? Yeah, because combinations, it's combinations, it's not permutations. And okay, so we take the sum of the combination. Then, okay, so this total minus the sum of the combination. If it's negative in the end, in the result, we skip it. If it's less than minimum, then we continue. And what we do, we split numbers to fleet. What do we split? The comb. But comb is a list, right? This is comb. Why do we split it if it's a list? Okay, we split it by space. I believe something happens here. How can we split list? We only can first. Okay, but docs Raku list class list and split method routine split. So courses the array count to string and splits it into okay, so yeah, I mean all those types, but here it's an implicit conversion to string, right? Because we already have elements. Why do we have to? And after that we convert. So yeah, I don't quite understand this step, because it's, for me, it's just just this is enough, right? Okay, nevertheless, so yeah, otherwise, if the sum is the same, we split it, and if there are less elements, then we keep these new numbers, right? Okay, finally we found the combination which gives us the minimal sum with minimum number of flips, and obviously we want to print this and some explanations if we need to do that. Okay, Raku Athanasius Raku 2, so it was 12, 2 and 100, and the output is 2, gives the result. Flipping the sign of two elements 12 and 2 gives the result 86. This is very correct. Good. Colin Crain Raku 2. So we start with the main function, which takes something, and it should be otherwise. If there's nothing, we just provide it with some 10 random numbers between 1 and 500. Base sum and array elements, base sum, so again, combinations minus double sum of the combination, and result, we keep it in the hash, where the key is the minimum. What is minimum? Is it a sum or? Yeah, it is a sum. We're done. Cannot do better. And after that, we remove the base sum and we take the minimum. Right. Okay. Strip negated elements from source. Okay, yeah, that's clear. Okay, Raku, Colin Crain Raku 2, 12, 2 and 100. I believe we had already something like this before, and if I will do this, I want to fix this solution because I like to see the output. So Raku T 12 to 100. Line number 2, this line. I can do it like this, right? Sorry. I mean like this, right? Yeah, so this is the combination, the found combination, some other things, but definitely the whole line is not needed in this case. But what was cannot modify an immutable bool? Which bool? I mean, yeah, the idea was like that, right? And now it works, so you cannot do it like this. Okay, good. Daniel Mita, Raku number 2. We take some numbers, positive numbers. There are at least 2 elements. Again, the Unicode character. All of them are rational numbers, and all of them are positive numbers. And the function returns nil. We saw another error in one of the previous reviews. Maybe in the future reviews we saw that. Right, so, and after that, so the body is... Ooh, that's strange. So we take the zeros elements and the number of them and say it, but what we do, we take the combinations. Okay, so again, so yeah, the whole sum is less than the half of the sum, right? And then we sort it by some criteria just to take the first element. I don't quite understand why we need it here, but nevertheless, Raku, Daniel, Mita, Raku 2, 12 to 100. Yeah, but I believe I know how to fix that, because we already saw something like this. This is what causes the problem. And then we just can run this one and the result is correct. So yeah, I don't understand when actually Raku broke this thing. Right, Jaldhar Vyas, Raku 2. So we take some numbers. Minimum is Unicode infinity. Result, and for the... So we scan the indices and we take all those combinations. This is the combination, the current combination, the current set of indices. And for those, so we scan then indices within the combination and we flip. That's the straightforward. I like it. Yeah. So basically, so there are two approaches to using indices. First, to use the Boolean representation of numbers, and then the second one is just to use the combination of all those things and to negate the sign. Right, after that, the total number is the total sum is the sum, which already includes some negative numbers here, the numbers with flipped sign, and as soon as this is a copy, we do not modify the original thing. By the way, this is a really good thing, because actually I also thought a few weeks ago, maybe a few months, that this construction just creates a kind of link, and if you modify lowercase a, you will also modify the capital cases, but actually this is not true. This is a true copy, and you can work with this copy, which is really cool. And if this is less than this one, the only thing I don't see here is that we also want to modify the length of this combination, right? So, but this is never checked. So actually, maybe my example, because after that, so you put result. What is the result? You did not push through to the result. You just assign this result, right? And after you grab it, what if there's only one thing in this array already, and it gives us... so we only keep the positive thing. So this, I believe, is always... Wait. What is there in the result? In the result is actually is this, right? It's not a sum. Sum is here, and result just takes all the... I don't understand. So yeah, what is inside A? The size of A is always the same size as the size of capital A, right? And this goes to the result, and then we grab result. Okay, so we grab the result to remove positive or zero. Okay, so this is how we count basically the number of minuses in the string. So we just count the number of elements which are below 0. Okay, now I see it. Okay, right. No. Raku, Jaldhar, Raku 2, 12 to 100. It gives us 2, which is correct. Good. Julio de Castro, rock number 2. So, right, that's a big solution, and it needs some syntax highlighting for us. Not that much, but still helps. So count flips of integers that we get from the command line arguments, right? Which are int in this case, if we pass integers in the command line. So we take the maximum as the sum. Notice that this is a binding operator, not it's not just an assignment. And we take the list and we make it sorted after that. So there are 3 subfunctions, subroutines, and they're multi-subroutines, count flips, and they differ by their arguments, obviously. But what do they do? And you see, so count flips, process next element, update. Yeah, I don't quite understand why we need this. But okay, so shortcut for... So in both cases, in both the first 2 things, we just return the flips. But here the flips... yeah, okay. So basically this starts, so it passes the position, the flipped thing, and the accumulated thing, right? And initially we pass, so how this procedure works, so it count flips. Oh my god, wait. Count flips is the name of the outer subroutine, and there are also a number of inner subroutine which are multi-subroutines. Oh my god, how does it work? I mean, when we call this, I believe it will call one of multi-methods, and if you call this one, yeah, it also will call one of these multi-subs, because we pass 3 named arguments, and these functions, multi-functions, they expect named parameters, right? And this one, it's not a multi-sub, and it expects, yeah, a list, which it will, yeah, the opposite of flattening, right? Slurpy. And so, yeah, I believe this one calls one of these functions, or the same function again. But, yeah, I find it really strange that the functions inside the functions have the same name. But okay, nevertheless, so if this is less than the maximum, then we take the next thing. What is the next thing? What is flips? What is flips? Flips number. Okay, so we increment flips basically, right? So the number of flips initially is 0. We increment it, and as the accumulated thing, we pass the number either the same or the same plus the next element. I wonder where we have minus. I don't understand how it works. Right, so Raku, Julio de Castro, Raku, 2, 12 to 100. The result is correct, and if, for example, this is 10, the result is 1, and this is also correct. Okay, great, yeah, and there are some test cases, probably, yeah, well, definitely they will all work, and that's cool. I wanted just, yeah, so you see, so there are 3 flips, so it's not like always checking 1. Notice this one, by the way. Okay, good. Laurent Rosenfeld, Raku number 2. Again, no syntax highlighting from GitHub, which is a shame. It's like already a year past since Raku is there. Right, so we take some numbers from command line, or we take some predefined values. After that, where do we start? We start summing up thing, the original thing and the used thing used so far. And if there are less elements, well, sorry, if, yeah, how can it be less than 0, right? If there are no elements, I believe, right, in the left array, then you do that. You just compute the sum of the right thing, and you push the result if the sum is positive, right? So if we can use this. Otherwise, you take the element from the left thing, and you recursively call the function again with, yeah, you recursively, yeah, you basically create a recursion tree with plus item and minus item. Yeah, we saw this already. That's really an interesting thing. And after that, so we just take the minimum. So simple so far. Right. And all this, after this, what we will get, sum up. So I believe after that, we will have this result hash, right, with some sums, and we are pushing there the sum as the key, and the use so far values is the values. So that's why we need the minimum sum. We find it minimum sum as the plus $_, and so this is key, right? And we take the minimum of them. And why do we need this actually? And if this first thing here is an integer, then you where is this result goes to? Where does it go to? So otherwise, so here we're saying something, right? Oh my god, yeah, so it's say number of negative numbers, comma, and actually, yeah, it appears here. This is what it's meant here, okay. And if it's not an integer, which is, what is there then we take negative numbers, and if negative numbers, some digits number of negative numbers, okay. Right, so Raku, Laurent Rosenfeld, Raku, 2, 12 to 100, some digits, number of, right, so where do we print these digits? Here, right, so this is the, yeah, this is what's there in the result hash against the minimum sum key, right? Number of negative, and after that, basically this counts the number of negative things. So here we take the thing and we scan it. I don't understand actually this one. So what I mean, like int, and otherwise you take this, right? Number of negative int. Okay, number of negative numbers actually comes from here, right? I believe, or maybe not. Okay, nevertheless. Okay, good. Myoungjin Jeon, Raku number 2. We take some numbers, and for if there are no numbers, no, wait, where, yeah, if there's one number, right, we print 0. Okay, if there are more and they're all positive, then we take the combinations of indices and we map those to, and in the map there's this pointer block, a function, anonymous function with a signal-less variable. Yeah, okay, so again we subtract the doubled sum, and that's it. So yeah, and this is for what? Finish under 4 seconds. And this is, I wonder how long this solution will, like in my case, Raku hash Raku 2 time. No, yeah. I believe, yeah, because, yeah, obviously. My solution, cat ash Raku 2 Raku. Here's the solution. My solution doesn't work with that because it just wants this solution here. So my A is, and after that I want to pass these numbers, right? Now I can, F space comma, but I only need to replace comma in this line. How do I do that? I don't know. Space comma right. Too much, but nevertheless. Okay, so I made it. That's the most important thing. Right, okay, so this is the program, and now I can run this time Raku T. Yeah. Basically, why is it so slow? Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like, yeah, 16. So yeah, that's really, yeah, because, yeah, we are scanning the binary things for that big number, and if it, yeah, so I see, so there's this parallel execution in theory, and actually I can run this on my machine. I can try this at least. Okay, but nevertheless, first let's Jeon Raku Che 2 Raku 12, 2 and 100. That's 2. Now we try to pass it with race, right? And finally I want to execute it with these numbers, right? With these numbers, like this. So it should be within 4 seconds and it's, well, what is it? Yeah, it is within 4 seconds, right? Okay, that's good. So yeah, optimization in this case really important thing. Okay, Roger Bell West, Raku number 2. So what we've got here, it's FA, flipped array, right? So there's the sum. We go through the combinations of indices and we compute the sum minus double sum of those indices. Wait. It's not indices, right? So it's not the indices, these are the elements, right? Definitely, we don't have to. Yeah, so why should we use indices if we can just use combinations of those? And if it's positive and if it's less than probably the smallest sum and the smallest number of items, then we keep these values, and after that we can just print this one. Okay, Raku, Roger Bell West Raku 2. There are some test cases already built in, right? So it works. And finally, the solution here in this list is Ulrich Rieke. Here it is again, no syntax highlighting despite the use v6. Thank you, GitHub. Right, so but actually, why v6? Compute the sum of array and find a combination of all those numbers that add up to half the array sum. If we flip their signs, the array sum will be close to 0. Right, so enter array, and what do we need to type? Enter an integer, -1 to int, every time is different. And after that, the sum, we divide it by 2, and we take the smaller things. Yeah, actually, if some elements are too big, there's no sense to negate the sign for those elements. Okay, we'll make some sorting, smaller elements, right. And finally, we take the combinations of those smaller elements, the elements that pass this filter, and we add it to the combisums array, and we sort them. I wonder where, so in the first part, so it's one pass solution, right? So immediately find the correct solution as it looks like. Right, so Raku, Ulrich Rieke, Raku Che 2, Raku 12 to 100. 12 to 100 minus 1, the result is 86. Yeah, there's no, like, it's not said this is the result. It's not said how many flips we have there, but actually if this is the first part, then how many elements are there? I mean, first, so this is the elements, the number of elements, right? But or not, because we want, no, actually this is the number. Okay, so it's not that easy to print the number of elements in this case. Okay, that's good. So so it was task number 2 from week 83 of the weekly challenge. It's flip array, and yeah, so this week is done. So there are a couple of interesting, but actually the first task was much simpler than the second one, and we saw a number of approaches to the second task this week. So it's really interesting thing. Okay, so thanks a lot for watching, and hope to see you next time. Goodbye.